Okay, this is a cool induction problem, but a similar one was done in lecture. So it's really more practice for how basic cases and inductive step work together. So a really important problem to try and make sure it's all clear in your head what's happening, how that fits. Also, it's just kind of crazy. Like any number bigger than 17 can be made up of 7s and 4s. Like any number. I just think that's weird. But anyway, moving on, we don't want to start with our base cases for these problems because we don't know how many we're going to need. So we're going to start with the inductive hypothesis instead. And going to use strong induction. Start with 18 as the bottom because we're proving for 17. And up. And assume all of them. So this J is going to allow us to say 18 up to and including K. Oops, I'm hitting the wrong buttons. There we go. Wow, where did my screen go? Come back. Thank you. Sorry about that. So assume that this works for any number between 18 and K. And now we want to prove that this works for K plus 1. You don't have to write this line. I sometimes do to help remind myself where I'm going. And now we're going to use similar logic that lecture did. If we know that 4 cents back from K plus 1 works, then we just throw an extra 4 into that pile, and we've got K plus 1. So what is 4 back from K plus 1? That'd be K minus 3. So if P of K minus 3 is true, then add a 4 cent stamp to the stamps that make up, this is a lot of writing, make up K minus 3. So P of K plus 1 works. You might want to add some more words to the sentence. I'm trying to not make this video too long. So we proved P of K plus 1 works, but only in some situations. So we got to make our base cases fit with all of this. And this is definitely the hardest part. I tend to just kind of start and see what works and what doesn't. So we know we're definitely going to need P of 18. In mathematical induction, we would also need P of 18. That's the very bottom rung that we're starting at. And now let's just ask ourselves if we need P of 19 or not. And let's look at the logic we used in the inductive step. We looked 4 cents back. Well, 4 cents back from P of 19 is P of 15, that we would add 4 cents to 15 to get 19. And we don't know P of 15. We're starting at P of 18. So we can't use P of 19 in the inductive step. So it must come in the base case step. We're just going to have to prove it straight up outright. Now the same deal, P of 20. 4 back, P of 16, still too low, not going to work. P of 21, 4 back is 17, getting closer, but still not going to work. We're not there yet. And then P of 22. Can we use our inductive step logic to prove P of 22? Well, if we look 4 back, that's P of 18. 18 plus 4 is 22. So yes, now that logic in the inductive step works for P of 22. So doesn't need to be a base case. We're going to be off and running with the inductive step from there on out. So 4 base cases. And now we need to come up to our assumption and what we wanted to prove and clarify a little bit. This doesn't work for any K. Like if I assumed, if K was 19 and we ended up just assuming that J between 18 and 19 worked, we couldn't prove anything. We need 4. So K has got to be greater than 21. For this inductive step. And so that's kind of, this K part is kind of what I meant by like, maybe I mentioned, maybe I forgot, that the hard part of this problem is making sure everything works together. And so we can't know how things work until we do the logic of the induction step. But then once we do, we had to change the inductive hypothesis a little bit. We had to pay attention to our base cases. It causes lots of problems. So just something to be careful with, pay attention to, if you ever aren't sure if you covered everything, just start at the bottom number you need to start at. Here it's 18, and make sure every number works. 18 works, 19, 20, 21, 22 works because of the inductive step, and then we're off. Okay, I hope that sounds good. Of course, follow up with questions on Piazza or email